Just validating my screen share is okay.
Yeah.
Yeah. All right. Thank you. All right. So we're welcome to week 7. We're just going to be continuing down, doing a bit more on the network security side. Right here's the overview. Today we'll be covering a bit more on firewalls, VPNs, and there's going to be a firewall implementation lab. Um, Day 2, network monitoring, and I think with day 3 we'll be talking about intrusion detection, prevention, and there'll be a snort, which is the intrusion detection system. Kind of like I mentioned the other day with doing network scans. We're going to do a lab to kind of demonstrate how IDS should be alerting if you're doing a network scan. So we'll be doing that. I wanted to cover the lab from last week. One of my VMs is frozen. I'm waiting for it to be rebooted. We'll go over the first slide deck, take a break. I'm gonna see if my VM is unfrozen by then, and then we'll possibly do that lab demonstration hopefully today. If not, I definitely want to get to it once my VM's up and running correctly. Yeah, so we'll go ahead and get started with the firewall section. So we've talked a bunch about firewalls already. We've talked about, at its base, it's the, it kind of uses the term right here. It's a barrier that's, protecting your network from a trusted and or untrusted zone. So, you typically see firewalls separating the internet from your private internet or your corporate internet. But as we'll kind of discuss, and we've already touched on earlier, there's a lot of different types of firewalls, and in this presentation, we'll kind of go over a few specific firewalls and configurations. Just a generic firewall diagram. This is somewhat representative of a lot of people's home internet connections. You have for example, the internet going to maybe a Comcast modem that's in your house, and you see firewall represented there. But a lot of like I've said, most modern devices, network devices, are doing it all in one. You have your home router being a switch and also being a firewall as well. And in even some cases, Comcast, they'll send you a modem that kind of rolls it all in one. So, and you might have a diagram where it's a modem, router, firewall all in one, but essentially there is a firewall operating logically, at the edge of your network coming from the internet space. And important thing to call out, like the modem that you're typically have if you are running like a Comcast in your house, it actually is getting like a public internet IP. So it is, that one end of the modem is being directly hit by the internet. And if you were to plug your computer directly into your modem, you'd actually see some pretty interesting things where it would be attacked. I mean, and so we'll get a bit more into it. In that example, I'll talk about a bit more. So firewalls, there's a lot of different firewalls, but it's a basic. We talked about the OSI layer. The firewall is doing some analysis. And at a minimum, it's looking at layer 3, layer 4, looking at, from the layer 3, what IP addresses, what networks the packets are going to and from, and then taking a look at layer 4, what protocols, what ports is your packet going, to or from, and then rules are being applied based on your firewall taking analysis at those layers. And is this IP space authorized to come into the network? Are we blocking geolocations? Are we blocking places like Russia, things like that? And then are this protocols allowed to come through? Are we going to let SSH, remote desktop protocol, any of those types of things come in through the internet into your home network or your corporate network? So at a minimum, that's how it works. And we touched on earlier some other types of firewalls that can do a bit more advanced analysis, and then we'll get a bit more into that as well. And right here, so packet firewalls, that's the main type of thing we've been kind of all our labs have been based around. It's looking at network packets, network layers, filtering based on those rules. What IPs are allowed, what protocols, ports are allowed, and as it states at the end, they don't inspect the contents of the packet. It's just looking at the layer 3 IP header, looking at the layer 4 TCP or UDP or ICMP header, and making a determination to what to do with the packet, drop it, reject it, forward it onto a different area of the network. Stateful. So this is where it's taking a look at where did the packet originate. A lot of times a good example of this is you have all these end users inside your network, inside your firewall in the trusted space. It reaches out to a web server, maybe a website, just to do basic web browsing. So what the state is, it's that connection's being initiated by the trusted side of the network. And when that traffic comes back on whatever port that it's returning the data on, it's looking at that state of the network connection, saying, okay, this is allowed through. This was initiated from a host inside the trusted end of the network. So we're gonna let the return traffic back in based on the state of the connection, versus if network traffic's coming in from the untrusted side, the internet in most cases, and it's let's say it wants to come in through whatever port, like a random port, it's going to look at it and say, hey, this is being initiated by the untrusted side, and there's no corresponding traffic for a host on the trusted side wanting this traffic to come in. So it's going to go and likely drop that network traffic. So and most firewalls have to function this way because when you're making a web request, you're reaching out to known ports like web server ports, like we've talked about, HTTPS or HTTP. So it's going to reach out on port 443 or port 80. But when that web server sends the traffic back to your machine, it's going to be in a what they call a random high port. And so this is where the firewall has to understand, okay, this host is going to expect traffic back on this port, and it'll let it through. Proxy firewalls. So again, this is something you'd typically see more in a corporate environment. A lot of times, they'll push web traffic through a special firewall that's designed to take a look at web requests for the purposes of, it could be for two things. One, it could be just to optimize the bandwidth. Everyone's going to similar sites. It'll actually cache image files, cache static files. That way, when everyone on the network's reaching out to these same websites, it doesn't need to re-download it from the internet. It can just catch it, get it from the local corporate cache and kind of reduce bandwidth usage. But on the security side of things, this is where a lot of people will want to filter URL traffic for, like a good use case that I use all the time is, we have phishing sites, brand new phishing sites get stood up every day. Somebody reports it, or we somehow detect it, and then we want to block our users from reaching out to that. Because users live all over the internet now, especially with everyone working from home. A lot of times, everyone's coming into the internet through their home firewall. They may not be on the VPN. So this proxy firewall can be configured so that, hey, everyone's regular traffic is going to go through, their home router internet, but we want their web browser to go through, in my case, the GoDaddy proxy firewall. That way we can filter out traffic, whether people are sitting at home on their home internet, or whether they're at the airport behind whatever firewall the airport has. So proxy firewalls are typically used for web browser traffic today. So we issue people corporate laptops. Unless you're an admin, you're not going to be able to change certain configurations. So most users can't change their browser proxy settings. So we'll force a policy out to all the corporate devices, so that way their web browsers go through a proxy. That way, if people click phishing links, um, it should, in theory, block these malicious sites, even if they're on their home internet. So this is where kind of things I've seen this evolve greatly with people being working from home and less in the office. And next gen firewalls, there's some terminology here. Deep packet inspection was a big buzzword at the time. But in short, these next gen firewalls, they're able to analyze traffic, figure out what kind of application is used. So it's looking at all the way up the top of the OSI layer, looking at the application layer. I've worked with Palo Alto next gen firewalls. You can filter by, I want to block Facebook, or I want to block YouTube. I want to block gaming. It's really good at blocking. I think they have like 1,000 different plus protocols that they've specifically identified. So you can be really granular at what kind of traffic you want to block. And then at that example, it's like, you can't block port 443 for blocking YouTube, because you're going to block pretty much everything that reaches out to 443. So this is where that next gen firewall is doing that analysis and figuring out what specific website is on there. An important thing to call out though with the next gen firewalls, because they are analyzing each packet before it comes through, it can add delay. So you don't want to use these next gen firewalls where we might have, let's say we're trying to have a conferencing, like we want to have, low latency for our conferencing software. So you might want to like configure it so that way, in this case, Teams is not being, going through the firewall. It's just going straight, zero latency. Or maybe if you're hosting content, like, if you're like a YouTube or some kind of streaming provider, you don't want your traffic to be delayed through getting getting analyzed by a firewall. You want that traffic to just get out as quickly as possible. And I think cost is also going to be, the more features, the more cost. And so all those things to think about. A lot of times, your your first two bullets is going to be the cheapest, and what I've seen standard in most places. And you only see these more advanced firewalls in when people have bigger budget. Why do we need to configure firewalls? Well, a lot of, at a bare minimum, firewalls turned on, it's going to be blocking very generic things. I think a lot of times you can get away with your home router firewall with its standard configuration. It would be just totally fine. But it's not gonna, we're not gonna have all the features we want out of the box with any firewall configuration. So it'll be, you want to configure, rules to allow, connections to your web server. You want to allow maybe remote administration, things of that nature, allowing your VPN connections. So, this is pretty, basic. You're going to want to make sure your configuration is secure as possible. So you're only going to let in ports, protocols, things that you need. And yeah, so that in short, you want to make sure your firewalls are always configured to your needs, but only allowing the traffic you need to get through. So firewall rules. So this is the general terminology across all firewalls. Whether it's we did the IP chains lab where we're using chains, or whether it's Windows firewall, across whatever application and you see, this is the terminology typically everyone uses to generalize what's being blocked, what's being allowed, what's forwarding traffic to. And as it says right here, they're typically um, actioned on from top bottom. So, the first rule on your firewall might say allow web traffic, allow HTTP port 80, port 443 HTTPS, something like that. And at the very bottom, the best practice is to let it end with a deny. That way, starting at the top, it's going to allow, 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 and at the very end, anything that's not being allowed through the firewall is going to get blocked. That's what you definitely want to have on your internet-facing firewall. It's better to block out any potentially bad than the opposite. If you were to just put uh, allow all, the firewall is just going to be a paperweight. It's just going to let traffic in and out without any restrictions. So, but for the purpose of troubleshooting, I've seen people do this where they're trying to get an application working and they allow everything in just to validate that it is a network issue, as opposed to maybe the application is not responding. So very rare incidences where you would potentially do that, and you want to make sure it's very temporary. I've seen people just turn the firewall off because somebody's complaining that stuff's not working, and never turn it back on. And yeah, it's never resulted in a good end result. So, but everyone's got different priorities. So I've absolutely seen this happen. So there's a number right here is a bunch of free firewalls. I think in one of the labs, we're either going to be messing with either pfSense or OPNsense. But out of all these free firewalls, I've only got experience with pfSense. I think that's a really awesome free firewall. But these are also good things to reference. And of course, iptables is the basic program that just comes with Linux. It's not fully featured, but at a bare minimum, it is a firewall. And then these ones are going to be your big name commercial grade firewalls. Cisco ASA, at one point in time, they're just the leader in the market. And then Palo Alto I remember them becoming one of the first people to kind of really coin the next generation deep packet inspection, and that's the one where those two are the ones I probably have the most experience with, between Cisco being a huge market share holder in the government DoD space, and then Palo Alto kind of just taking over once they started coming out with their new features. But I do know that a lot of these other firewalls today are, they've all adapted to do a lot of the similar things. I hear good things about Fortinet, Checkpoint, Barracuda. All of these I've kind of at some point in time been just overviewed from partner teams and things of that. So now we're going to kind of spend a little bit of time talking about a few different firewalls. The first slide I was talking about, if you were to plug your computer in directly to a modem, without plugging into your home router that has a built-in firewall, your computer is going to be directly hit by every attack on the internet that is constantly scanning and going on 24/7. Old versions of Windows never had a built-in firewall. And actually, in the innocent days of the early internet, that's exactly what people would do. They'd have their modem plugged directly into their computer. The computer would get assigned a public IP on the internet. And I remember being, young in my career then, you could ping of death other users on the internet and just crash their computer. There's all kinds of, it's crazy back then. But today, Windows has built-in Windows firewall turned on by default. So every Windows computer, unless you specifically disable it, is going to have a Windows firewall. Windows firewall by default comes with a few different profiles. And what these profiles are, you can set different rules for what they call public, private, and domain. Um, for most home users, private and public are going to be the profiles that you see. So a lot of times, like Windows is decent at being able to figure out what can automatically be private, what can automatically be public, but you can always specify specifically. So, by default, it's going to figure out what your home internet is, and it's going to consider that a private network. So, um, and then like if you go to a coffee shop, airport, hotel, Wi-Fi, sometimes it's pretty smart to figure out public or private. Sometimes it will prompt you when you connect to a new Wi-Fi or plug into a new network. It might ask you like, is this a public or private? And then of course you can always uh, go in, right click on your network settings, and then go ahead and say it's private or say it's public and do that. And then what this does is you can have different types of settings for your public versus private. On my home private, like I want to be able to automatically discover like my network print, my printer on my Wi-Fi. I don't want to have to, figure out what IP it is and all that stuff. So I'll go ahead and say like, I'll click turn on Windows Network Discovery or something like that. Versus, you don't want to have that on when you're at a public Wi-Fi. You don't want to open up your computer to other people, trying to scan what's on the network on your computer. So yeah, so those are the two basic profiles and configurations. The domain profile is more for a corporate profile. So when I have my Windows computer on like a corporate network, you typically are your computer is joined to your corporate domain. So it will have a profile that could be specific for when you're on that corporate network. So at its heart, Windows Firewall has those different profiles. And then within those profiles, if you look on the left of this diagram of this screenshot here, inbound and outbound. I think Windows Firewall did a pretty good job of keeping it pretty simple. Inbound rules is what you're allowing to just come into your Windows machine. By default, you shouldn't have too many Windows inbound rules. Like for example, network discovery, file sharing. That's not on by default, but that's something that you would turn on a private network if you want to be able to share files. If you're running any type of server, like if you were to set up your computer as a web server, file server, you're going to want to configure inbound rules to allow other machines on the network to come into your computer. So that's that's where you would configure these inbound. You'd go into you'd click on inbound rules, and then it would pop up, say, it's a new, you'd create a new rule, and you just say allow traffic on port 80 from anywhere or from my home network or whatever you want to make it. And then outbound rules. So a lot of applications that you install on your desktop, they need to reach out. A lot of times, for example, we're Edge right here. It's a program on my Windows machine, and it needs to be allowed to reach out. A lot of times when you install a program, it's asking for that admin rights. It might ask you it might prompt you if it's saying like, oh, you want to allow this program to connect out. So, browsers, when you install Edge, comes with the computer, it figures it all out. But maybe you're running some third-party application that needs to reach out. Maybe it's you installed WebEx or Zoom, for other conferencing platforms. That's where it might prompt you to say, hey, it wants to be able to connect out to the internet or your local network. So yeah, so anything that's pretty much any application you install on your computer is running through an outbound rule on your Windows firewall. Security rules. So this is where you can actually, we talked earlier about older VPN protocols like IPsec. You don't need to download a third-party application. So actually, in modern Windows, this is where you can configure some special connections that Windows supports without any third-party software. So yeah, this is one place you can set up a VPN. But again, like we talked about last week, so many modern VPNs are leveraging these corporate pushed things, or maybe like these free Surfshark. I rarely see people going in and configuring IPsec on their Windows or Linux or Mac machine, but it's there. This is where you'd find it, and this is where Windows supports it right out of the box. Windows Firewall. So we also have monitoring here. So even though this isn't like a a fully like you're not running a commercial grade firewall, Windows Firewall can actually still do monitoring. You can actually look at it, and it'll tell you if connections are being blocked and what's being allowed through. It does a pretty good job for some basic monitoring out of the box. Yeah, right there on the left side under inbound, outbound, connection security rules in the very bottom, monitoring. If you go into that, you'll be able to see where what actions Windows Firewall is taking. All right. We'll kind of talk a little bit about pfSense. I kind of mentioned that this is probably my favorite free firewall out there. It's if you've got no budget and you need a firewall, you can build a pfSense firewall pretty cheap with any hardware. I want to say it's Unix based, so it's command line at the bottom, but it actually has a graphical user interface. So even though it's Unix based, you can actually, once it's installed up and running, you can configure it using a graphical user interface, and it's pretty intuitive and not that crazy to use. So just like every technology, they each have their own terminologies. So pfSense uses interface groups. You can kind of treat it like the public private domain that we were just talking about in the Windows firewall. But you can it's basically using its own terminology. So you can take multiple interfaces on your pfSense and just call it home or corporate or internal, and then you make your internet interface would be like untrusted or internet or something like that. So and it comes with some default ones as well. And there's some basic steps right here for creating your interface groups or editing them in pfSense. To basically name, description, and then you pick which interfaces are going to belong to those interface groups. And here's like I said, there's pfSense has a pretty rich GUI, and here's an example of creating that that interface group. This example right here, group name, local networks, and the example of the group members is your LAN, local area network, and I don't think we talked about demilitarized zones in networking, but you can select these two groups, and like I said, I don't think we talked about demilitarized zones. So DMZ is a term in networking where could be one or more hosts that are in your internal network, but they're designed to be exposed to the internet. So for example, if I'm hosting a web server on my home network or my corporate network, I want my web server to sit in a space where the internet can reach it, but I don't want this machine to be able to interact directly with any of the other hosts on my internal network. So by default, a lot of these network firewalls, network routers, if you were to classify something in the DMZ, it's going to expose it to the internet, and it's going to segment it from the rest of the hosts on your local area network. So yeah, so that's what that is. And to be honest, in this screenshot, I likely wouldn't put the DMZ in the same interface group as my local area network. I would want separate permissions for these things. So But yeah, just here's an example right here where they're taking two interfaces and assigning it to an interface group. Um, I think a better example might be like, um, maybe I have an interface that goes to my, my my switch in my service in my where my users connect to the internet, and another one that goes to maybe my internal servers that aren't meant to be exposed to the internet. So maybe I call that my local networks, and then I give the DMZ a bit of a different type of configuration. So, but in this example, here's what it would look like if you're configuring it. Pretty simple on pfSense. And just like we were talking about earlier, like we are adding, we're creating essentially these zones, public, private, local networks, whatever it is. So then we can therefore next apply rules. Um, just like we're in talking about user administration, creating groups, so you don't have to apply configurations one user at a time. You always want to, for ease of administration, you want to create as much essentially you're giving it that role-based access design. So you don't have to apply rules to every single interface if the interfaces are going to have this, the same types of things being configured for them. And so just like we all out of the firewalls, there's a processing order, but pfSense does have its own terminologies. Floating rules, they are like rules for everything. You could just set it, you could consider it at the very top. No matter if it's interface group agnostic essentially. So you put a floating rule, maybe block Russia or don't allow torrent traffic or something like that, and it'll apply regardless of interface group. And then the rest of the rules are going to go top down for interface group. And then if you want to be more granular below that, you can do it for a specific interface. So there's essentially a hierarchy for pfSense, just like there would be for just about any specific firewall solution. Um, and I would say, it says right here, best to avoid using interface groups with multiple WAN connections. Um, yeah, so this is just a best practice here. I would agree. I mean, I can't think of a good use case where I want to apply rule like bunch up two different WAN, and WAN is the wide area network interface, which is typically the internet connection for your network. Most times, lower budget, you've got one internet connection. And this is where if you have two, you typically don't want to treat them the same. Like, for example, a lot of times you have that backup internet connection. So maybe you want, different rules for that. So this is just where it's best practice. You never know though. There's always an edge case where maybe this is something that you might want to do. All right. The last firewall that we'll just kind of overview, Firewall D, which is meant for like firewall daemon, which is it's Linux based, so you can actually install it on most Linux distributions. And then the lab that's for today is going to be doing some configuration with Firewall D on the I say it's either the Ubuntu server or the Kali server. So that's where the lab is for today. But yeah, so Firewall D, it's command line. It's very simple or similar to the uncomplicated firewall that we did in the Ubuntu lab some time ago. And yeah, we'll kind of get into some of the things. So, just like for some of the other services that we started and stopped in Linux, this is the basic system control command, start, and then enable the firewall D, and then check in the status. So this will be part of today's lab. And then you know just like we have public, private, domain profiles for Windows firewall, and then interface groups for pfSense. The terminology for firewall D is zones, which zones is a really common terminology that a lot of firewalls use as well. I think Cisco uses zones for their for this same purpose. So you got to take a look at what zones, and we have right here. It uses public, which is very similar to the Windows firewalls. And then some example commands for adding and removing ports to your firewall. In the lab, you're going to go ahead and turn on the firewall and test it out doing I want to say we're going to be testing out with the Apache web server. So I think, part of today's lab is going to be installing Apache web server, turning on the firewall, and then from the other host, trying to connect to that web page that you just briefly created. And of course, just like anything, there's tons of cheat sheets out there. This is a good cheat sheet for the firewall D firewall. Mm, All right. Any questions on firewalls? This was just, a few different firewalls. You get a little hands-on with firewall D, and I want to say Windows firewalls in some of the upcoming labs. But yeah, questions, thoughts, concerns? All right. We'll take a 10-minute break. We'll break till 6 p.m. Pacific. I'm gonna go see if my Windows machine is unfrozen, and possibly we'll cover the lab from last week. If not, we've got one more module to go in before we talk about this coming week's labs. So I'll be back on in just about 12 minutes. So yeah, 6 p.m. Pacific time, we'll get back started. There we go. I was talking on mute. Just as I was checking if my audio is okay. You guys can hear me okay? And screen share good?
Yes, we hear you. Okay.
Yeah.
Thank you. All right. One more relatively quick section to cover. So yeah, my virtual machine's still frozen, so I won't be able to do the last week demo. I still have it on my to-do list because I think it's a good demo. So might try it out on. I'll keep it on my to-do list for Thursday. But yeah, so the next section here, virtual private networks. And we're just going to go a bit more deep, even though we've talked a few times about some VPNs as well. So VPN, the terms have evolved a lot over the years. A lot of time, before VPNs meant something much different. And we'll kind of talk a little bit about that in the next slide. So, or the next couple of slides. But in a nutshell, VPN, it's virtual private network. It is a way of traversing a network connection to connect two networks. Either whether you're connecting over the internet, trying to get to a private network that you only want authorized people to connect into, or potentially in older technologies you might be traversing a telephone connection even to get to a virtual private network. So at its roots, VPNs are using some sort of connection protocol and configuration, whether it's special software or it's configuring built-in protocols to connect you from one point to another. VPNs, they use encryption. I don't think there's any VPN protocol that is unencrypted to my knowledge, and it allows you to route through the private network. A lot of times, you have applications that are accessible only from quote unquote the corporate network or quote unquote the internal network. And a VPN allows people to access those same resources as if they were at the corporate network, whether, back in the day it was whether you're just traveling, and then nowadays work from home is just so common. So, but yeah, VPNs allow you to route through another network as if you were on that network. And the other purpose of that can be to hide your real IP. A lot of people are using free or affordable VPNs to maybe stream movies and appear there from another country, or maybe they just want to have that privacy. They don't want, excuse me, they don't want to be seen browsing from their own personal IP. There's whether you've got a tinfoil hat or whether you just are value privacy, VPN does do that. And I think that those are the most common use cases for VPNs. But even though you're going through a VPN, a lot of times you hear these commercials on YouTube about using Surfshark to protect you from bad stuff. Some VPNs are gonna block malicious sites for you if that's what they're marketing to, but not all VPNs implement security. Some simply are just providing you an alternate route so that you don't need to. It's just for privacy, anonymity, and not necessarily for security. So even though you're on a VPN, a lot of VPNs still gonna let you connect to malicious websites. It's not gonna stop emails from getting to you. It's not gonna stop malware from getting to you. And on top of that, you still have to implement all the strong authentication MFA factors. I think we may have covered some of these before, but the different types of VPNs. I'll start. So remote access VPN, I think that's a typical type of VPN that you would see when you're trying to do work from home and access your resources on company internal systems from travel or home. I would say client to site VPN. This is similar. Again, I think when I mentioned this before, I don't think it's a very commonly used term or product today. But it is still available for some niche use cases. Site-to-site VPN, this is a lot of times connecting two offices that are, within the same company. For example, this could be just, it could be a large company and all their sites with different states are using site-to-site VPN so that they can be a large corporate network without necessarily being geographically co-located. So you can have your Washington office have a site-to-site VPN to Texas or wherever, or all the way to another country if that's the use case. But it's meant to provide that same type of connectivity if you were, in a large campus or a building, where everyone's in the same actual network. Layer 2 tunneling protocol. This provides so layer 2, that's like our switching, or you're plugged into the same switch, so you can actually tunnel layer 2 over the internet, and it'll provide that same connectivity it'll be transparent to the users plugged in, like they're plugged in onto the same network. So it provides that VPN type of functionality, but it's seems a bit more transparent, whereas site-to-site VPN is using a router to route that private connection together. So both of them are, there's a lot of different technologies out there that you can leverage that kind of, mostly depends on how your network is configured. Yeah, so we just talked about layer 2 tunneling protocol. Really neat, just I would say it's not so much used anymore today because everything's kind of configured with this work from home in mind. Nobody's networks aren't so much configured today where everyone's plugged into the same network and sharing files across the local area network. A lot of the technologies today are, more have that zero trust model designed for majority of people working from home. So layer 2 tunneling protocol, not so common today, but it's still out there in some use cases. More commonly, SSL VPN. So it's using that HTTPS to connect out to a remote VPN server and then tunneling through that connection. And I think I mentioned before, this one was really popular at a certain point in time because HTTPS is a loud protocol to get out to other parts of the network. You don't have to necessarily configure your firewall to allow special ports and protocols through the network, and you can establish this SSL VPN connection without doing much configuration to the network. OpenVPN. So this is actually really popular. You can just install it on just about any Linux distribution. A lot of home firewalls might have this available. You could actually go into your home firewall configuration, enable OpenVPN, and for free, you can have a VPN connection into your home network. So something that any corporation kind of do on a low budget. Point-to-point tunneling protocol, like it says, one of the earliest VPN protocols, not secured today, but this is also something free that you can set up using protocols and applications that are out of the box on a lot of operating systems. IPsec, so Windows supports this natively, and this is very commonly used today for site-to-site VPNs. All right, VPNs versus proxies. So, the last slide I was talking a bit about, the web proxies. And the important thing that kind of differentiates these things. I mean, they're both routing your traffic through another IP, so that way, you'll seem like you're coming from that proxy or VPN IP. Both of them can provide some level of filtering if configured, but the biggest thing, a proxy isn't necessarily going to be encrypted. So, important difference there. If you're using a proxy to connect to corporate websites, if it's not HTTPS, it's not going to be encrypted. So if for some reason there's an HTTP website that you're accessing through a proxy, just like any other unencrypted protocol, it's going to be open through the internet. So you want to make sure that uh, you just have that understanding that it's not encrypted just going through a proxy, but VPN encrypts all the traffic. I would say there's a caveat here. So, it states right here, a VPN encrypts all traffic. You can actually, if you're downloaded your own VPN, or if you're a corporation and you're pushing a VPN client out to all your employees, you can make that configuration change to not VPN certain traffic. Um, One of the things that you would likely want to do is filter out like YouTube. A lot of times YouTube's a very useful resource for your employees, so you wouldn't want to necessarily block that. But you don't want all that streaming traffic to have to route through your corporate VPN. So it's a lot of times you configure certain websites that you don't want to route through your corporate VPN. So I'll be on my work computer, I'll VPN into the corporate network, and then if that configuration is set up, all my traffic, with the exception of YouTube, is going to go through the VPN. So I'm not creating that extra bandwidth that if all your employees would be doing, they'd suck up a lot of bandwidth from your corporate connection. Some open source VPNs. I've only ever used OpenVPN here. I can't speak too much about all these other ones, but OpenVPN, I think it works great. And you can just install it on any Linux distro. So on Windows, you can even install it on Android and iOS, and it works pretty good with just about any operating system. Corporate use VPN. So these are all like widely used out there. Cisco AnyConnect, use that at my government times and at T-Mobile. Currently nowadays GoDaddy, we're Global Protect customer at Palo Alto. Those solutions work pretty great. And I think at the heart of them, no matter what solution you're using, you've got to take into account like how you're managing the users that connect to that VPN. Uh, I think the biggest, there's a number of threats here that are listed out. And I think the biggest one is malware and phishing. If your users are connecting to VPN to get into a corporate network and they're logging in with their username and password, that's just as vulnerable as any password can be intercepted. Users, uh, attackers are very much interested in trying to take corporate credentials to log into corporate VPNs. So MFA, very important for if you're going to be managing a VPN connection. I've seen so many VPN attacks where not having MFA, and we're trusting users that are coming into VPN, and it ends up creating a big security hole. IP leaks. So like I was saying, not necessarily all your traffic is, you can configure certain traffic to not go through a VPN. So there is that exposure with it says DNS and IP leaks, but depending on how a VPN client is configured, there's some things might not be going through the VPN. So it's just important to understand if there's any exceptions configured in a VPN configuration. I would say, of all these ones listed right here, uh, the biggest threat I'd say is VPN provider compromise. We you always put a lot of trust in your, we call it supply chain of applications, programs. I'm using Global Protect run by Palo Alto, but Palo Alto has human employees. Palo Alto has humans that make mistakes as well. It's incredibly likely that any VPN provider you use, they could have a compromised employee or a malicious insider, and they could gain some access to any network. So, and that's with any kind of application you use that you're quote unquote trusting. So it's always something to kind of consider. I always say treat everything with as little trust as possible, and create layers. That way, even if one of these things gets compromised, Maybe you have some alerting, you have you're not giving unlimited access to somebody who simply gets a VPN connection. They still have to authenticate. Are they authorized to use this application? Are they authorized to reach out to this share? So of the things all here, the one that scares me the most is the VPN provider compromise, because it's definitely happened. You can think of a lot of cyber attacks that lately where somebody always gets compromised somewhere. Best practices, I think. Um, I think the biggest thing I see here is the kill switch. Like I said, everyone's going to get compromised. You want to be able to disconnect a malicious VPN session. Uh, that you want to be able to say, you have like a phishing email that gets reported, and you start looking at which of my users has been received that phishing email, which of my users clicked the phishing email. All right, are any of them connected to VPN right now? Does this VPN connection look suspicious? Are they do they always connect from California, and then now I see a login from someplace completely different? Might be a reason why you want to forcefully disconnect a malicious VPN session. So I think that's the biggest thing that stands out here. All the other things, they're definitely best practices, but you always want to have that way to mitigate something that's been compromised. Right. That's the end of this slide. I think for the purposes of our labs, I'll double check. I'm not sure I don't think we're doing a VPN configuration lab, but I'll double check. It might be something that's coming out that way. Let me go over the lab that opens up for today. So this is let me go to Canvas real quick. So today our lab is going to be in week 7. This first one right here, implementing basic firewall functions, network perimeter security. In fact, I'll drop this in our chat right after I'm done presenting. But yeah, so here's today's lab and the labs for the rest of the week. So let's go over today's one. So essentially, you're going to create a web server on your Kali Linux box, and you're going to create a firewall and allow traffic through. So, we're going to go to our server, Hyper-V, start up Kali, start up your Windows 10 client. Like I said, every time I start up these clients, I need to walk away for about 15 minutes, let them boot up and get spun up before I want to start messing with them. So go ahead and start your clients. And then you're going to install Apache Web Server on your Linux machine. Get that up and running. And then, of course, we're going to start it. Assuming everything runs good, you have a working, running Apache Web Server. You're going to test that out. So, we know our Kali IP, we're going to be the .100 here. And browse to your Kali IP, and you should see the default Apache web page. So it's successfully installed. There's nothing on the web page, and here's just the default page. You're going to go ahead and install Firewall D on your Kali machine. Turn it on, make sure it's enabled, check the status, and you're going to create a custom zone here. We're going to do a little bit of configuration, add in the interface, and then you got to make sure you reload your firewall whenever you change the configuration. Validate it here. And then we're going to go back to our Windows machine, and we're going to do private browsing to make sure there's no cached web pages. It might, a lot of times you just browse to a web page, Windows is just going to reload the cached one. We want to be able to validate our changes we did are going to be in effect. So we installed the firewall. We didn't create it. We didn't allow any traffic through. You refresh the page in the private browser, and you should get an error, meaning the firewall blocked the web traffic. So now we're going to go ahead and configure an exception. You're going to add in some new rules that should allow these ports through. You're going to apply the changes, and when you reload, you should be able to reach the web page again. So now you're validating. You installed the firewall. It blocked traffic. You set some rules up to allow the web traffic in, and it should successfully load. That shows that you're up and running with your firewall, and you have the appropriate exceptions for your web server. You're going to install a few more hardening security modules on your Kali machine, mod security, edit some configurations on here. And essentially, this is going to be doing some hardening on your Apache install. See, it's so simple. So I would say anytime you're, I don't know if this step is in here, but let me see if they've added in. I don't know if you guys remember my mistake on one of the first weeks. Anytime I touch a configuration file, I'm going to back it up first. So I would say before you get to this step right here, go ahead and copy the file and just make do CP, and we're going to copy a backup file. That way, because anytime you're modifying these config files, they're going to let you make typing errors, spelling errors, things of that nature. So if you run through these configuration files, you reload it, you get an error, you can at least take a look at the backup and see, or you'll be able to at least correct back to working state. And then if you did any typos, misspelling, you'll have at least something to go back to. And like I said, I want to go over the lab from last week where we stole the NTLM credentials. And this last step right here is for configuring some settings on your Windows machine to make it so that those network credentials cannot be intercepted over the network and cracked. So a few more steps of network hardening. All right, a few other things. I'll be opening up Quiz 10 as well today. So that will be available. And like I said, I would copy the outline for the whole week as well into our Teams chat. I think that concludes for today. I'm not sure if Joel will be back in tomorrow. Stop sharing. Raven, are you in tomorrow for Joel? Do you know if he's back for helping with the labs?
Yeah. If Joe is not here, I'll be joining the class and jump in.
Yeah.
I'll
And
handle
then
it.
I'll be working on getting the Teams meetings rescheduled 30 minutes earlier. So like we talked about last week, the plan is for Tuesdays and Thursdays, we'll start 30 minutes earlier. I'll cover review for those 30 minutes, and then for those who can join, just kind of work out a little bit schedule during Ramadan month. And then we'll pick up with any new content by the time 4 o'clock sits. So I think that's a good compromise and then we'll end by 6:30 p.m. Pacific time to kind of accommodate for this month, and possibly we'll see how it goes. Maybe we'll stick with that same schedule for next month. Any questions? All right. You're welcome to get started on the labs. I'll be in for about 30 more minutes, and otherwise you can drop off and continue with the labs tomorrow. And we'll be back for the next few sections on Thursday. Thanks, everyone. Enjoy the rest of your evening.
Thank you, Ivan.
Thanks so much.
Yeah. How many students are you guys like joining every day?
I would say there's a consistent 3 and up to 5. So
Oh, yeah.
yeah.
check your machines, Ivan.
Exactly. Sorry.
Go ahead. Sorry.
Yeah. Is that the exact number that we are like? I mean, I saw the little number every day is like 3 to 5. Is that the whole class or some people not attend?
People dropped out thinking that maybe they're not,
Oh,
I guess, don't have the
I see.
prerequisite skills. So yeah, there's a few people that aren't going to continue on, but yeah,
I
so
see.
yeah. And I would say, like I was kind of reiterating to everyone, that week one, we're touching on so many different things, but that's just kind of like the boot camp style. We're not necessarily going to master it all. I think a few people got a little discouraged, but it's okay.
Well, I think in my perspective, everything is going really well. So, but yeah, hopefully
great.
it's gonna continue like that.
Yeah. All right. Oh yeah, and you can stop the recording as well. Thanks. So yeah, I just dropped in the outline for the week with the lab for today, and I just opened up quiz 10.